Okay, our next chi-square test is chi-square for two-way tables or chi-square for contingency tables. Contingency is a good one to remember because in StatCrunch, that's one of the keywords you're going to look for when you're selecting the correct procedure to do it. The chi-square is going to test basically this hypothesis: no relationship or no dependency against an alternative of a relationship exists or a dependency exists. So these hypotheses, the wording can change, but that's the idea about what's happening. So if I show you an example, and this is an example I've used for a long time, and it's talking about quality of life between patients in Canada and the US after, I believe, a heart attack. This is an old data set that I have. And this is what a two-way table or contingency table is all about. They're giving you categories. Are they in Canada? Are they in the US? And how do they feel 5 years down the line or a year down the line? Are they much better, somewhat better, about the same, somewhat worse, much worse? And when you're testing this, you're looking to see if there's any sort of relationship between these columns and these rows. Now, to the computer, the math behind it, the Canada and US are irrelevant, and these categories are irrelevant. They're just looking for what should the counts be, what should be the expected values or expected outcomes be compared to what you actually see. So when I run through the test, stat, so this is a two-way table or contingency table, so tables, contingency with summary. Okay, so you've already collected the data. The data has been collated and put into these different categories, so that's why it's summary. All right, so now these tables can be of different sizes, and I have Canada, I have US. Those are my columns. I could have 15 different columns. Right now I only have these two. So I'm going to select Canada and US. Quality of life is how they're being judged, these 5 different categories. So row labels will be that left-hand column. In this one is quality of life. Now, I need to select a couple other things. I like to click on expected count and contributions to chi-square. And I'll show you what I use this for in a second. And we'll just go and hit compute. And it's going to throw up a bunch of numbers on the screen. And if you want, maybe write these down, but they're going to show up right here. Canada, US. Here's my categories. The numbers without parentheses are my original counts. That's how people were shuffled into this. And I'm going to look at my p-value. Possibly I'm going to look at my p-value. Okay, there's my p-value, about 1.95, so at alpha of 5%, we're definitely going to reject. So when I reject, I'm rejecting the null. That's saying there's a relationship or a dependency between those rows and those columns. So when I go back in here, the next thing you have to do with a chi-square is try to determine where these changes or dependencies are. So what's really happening is it's looking for where your observed data, like the 541, varies from the expected. The first number in parentheses will be the expected. Now, a fast way of doing that is to look at the second numbers in parentheses. And when I look at these, you're looking for big differences. The smaller these are, the closer these are to 0, the less difference I'm seeing. Like here, somewhat better, nothing. Okay, these are pretty much nailed for what they expected. Much better, pretty close. If I get down here to much worse, 6.77 is screaming to me. That is pretty large compared to the rest, and that's a constant theme. You have to look for which one of these contributions to the chi-square is largest compared to the rest. And we're only doing this if we reject. So I'm looking here and go, okay, 6.77 is huge compared to the rest. Next thing I look at is my observed, which was 19. So 19, in this case, I believe it's Canadians, said they're feeling much worse when they're expecting to see 11 or 10.55. On the flip side, Americans, 65, are saying much worse when it's expecting 73. So these two numbers aren't what is being expected just based on the sheer percentages. So there's something happening here. If I go up 1.65, well, that is still large compared to a lot of these. 1.76, and again, looking at the numbers, about the same. They're expecting 109. 96 said about the same. Somewhat worse. As these get worse, somewhat worse, much worse, the numbers that are reporting are higher than what's expected for the Canadian side and lower for the American side or US side. So that is how the chi-square test is used. Now, it's not my favorite test. It's a little bit hokey in my mind, but it is a way to give evidence if you have a lot of different categorical or categories with counts to see, all right, is there something going on here? Yeah, I can look and see there is. Now, I'm not saying this means that there's a big difference in US and Canada. I'm just saying this particular set of data, there appears to be a relationship between these columns, which happen to have those categories of Canada and US, and these rows, which is much better to much worse. Okay, thank you.